Okay, let's return to the chicken model. Now, if you remember, I said that there were some problems with the chicken model. Let's now look at what those problems are and how we might be able to fix them. So, first of all, let's do a correlation matrix. Let's select our independent variables, x2 to x6, and click on OK. Now, if we look at that, we can see that all of our independent variables are highly correlated with one another. They're in fact have got correlation coefficients of over 0.9 in every single case. That's a pretty strong indication we've got a problem with multicollinearity here. Okay, how are we going to fix it? Well, let's have a bit of a brainstorm. Let's go back to the original model. This time we'll set the dependent variable as y by default, so it's for the others. This is our original model. Yep, we knew there were some problems with it. We could see that the price of chicken was significant and the substitute was significant. The price of a substitute was significant, but not income. So let's now think about how we could get around that problem. Well, one solution would be drop the insignificant substitute beef and rerun the model. So we've done that. Look at them side by side. Yep, lots of statistically significant things. Probably worth noticing the coefficient of the price of chicken has actually gone up quite a bit, so that's maybe a bit of a concern, but all well and good. That's one solution. Get rid of one of the potential causes of the multicollinearity. Another one, use a composite. Instead of having the price of pork in there and the price of beef, let's have the price of a substitute index in there. We tried that. Not that good actually, bizarrely enough. It's actually a worse model if we look at model 3. The adjusted R squared's gone down, and x6 isn't statistically significant at all. x6 is a composite price index, so that hasn't worked out as well. And notice the big change in the coefficient of the price of chicken. That's a really big change. It's dropped down from minus 0.54 to minus 0.29. That's a big change. Okay, we can see there's a Durbin-Watson problem there. And there was a Durbin-Watson problem there. Maybe if we fix that, things will improve. We looked at Durbin-Watson in the last tutorial. So, go back. Let's put x4 back in. Let's go back to our original model. We can run another check. Yep, have we got an autocorrelation problem? Yep, we have. Not massive. T-ratio is only 2.7, but it's still an autocorrelation problem. So let's do our Cochrane-Orcutt correction. There we are. Nice and straightforward. Yep, we got rid of the autocorrelation problem, but now we're saying the demand for chicken is just really a function of income. The price of chicken and the price of substitutes have no effect whatsoever. That's probably not what we want from an economist's perspective. Yes, the model is better statistically, but as an economist we're going, there's a problem there. Okay, something else I said earlier, if you remember, was maybe a time trend is important. So let's stick a time trend in. And that's interesting. The Durbin-Watson actually is okay now. The time trend is significant, income is significant, the price of chicken is significant. So that's actually not a bad model. Let's drop the insignificant variable, the substitute. Let's see what that looks like now. Like I say, Durbin-Watson, probably in an area of uncertainty. Do a quick check. Yeah, not a problem there with autocorrelation at all. So we can close that window if we wanted to. But let's just look at the model. So, income, significant. Quite a small effect. Price of chicken, significant. Relatively small effect. The big effect seems to be the time trend. The quantity consumed of chicken is going up by roughly 5/6 of a pound every year. That's an interesting phenomenon. As an economist, we could talk about that. That's something you might want to do if this was your model, but let's not worry too much about the statistics. But that's